Good evening, this is Mr. Wintermelon, and this will be the worst video you can watch to learn about the properties of enzyme and how does enzyme work. So in the nature world, chemical reaction occurs naturally. However, it can take really long, or it requires a high or large amount of energy, such as from heat or electricity. Therefore, you need something to speed up the reaction, a catalyst. So we have our enzyme. So please take out your notebook and copy down the definition of enzyme. So enzymes are biological catalysts. Catalyst is a substance that speed up chemical reaction. They remain chemically unchanged at the end of the reaction. So enzyme can catalyze the formation of product, or they can catalyze the breaking down of substrate. That means they can join two compounds together or elements together, or they also can break two elements or compound down. So here are some properties of enzyme. Enzymes are highly specific. The shape of its active site, we will touch on what is active site later on, is complementary to the shape of the substrate. This will allow enzyme and substrate to bind to form an enzyme substrate complex to lower the activation energy of a reaction, hence speeding up the reaction. We will also highlight what is activation energy later on. An enzyme remains chemically unchanged at the end of the reaction, hence they are only required in small quantity. For your O-level syllabus, all the enzymes are made up of protein. Therefore, they are sensitive to temperature and pH changes. Why is this the case? We will discover later on. And lastly, enzyme catalyze the reversible reaction. What does this mean? It means if you have a compound that is X and Y binded together, enzyme can break X and Y down, as well as the same enzyme can combine X and Y together. So how does enzyme go about doing its business? The hypothesis that you learn here is called the lock and key hypothesis. The enzyme is analogous to the lock, while the active site of the enzyme is referring to the keyhole of a lock. The active site of an enzyme is a groove or hole which the substrate or the compound to be reacted can be inserted into. The shape of the active site is complementary to the shape of the substrate molecules, just like how a keyhole matches the key. And every lock has its unique key, which is similar to how enzyme and substrate works. But of course, this is actually not the only hypothesis. There's another one that you will learn at higher level. And ultimately, in my opinion, the lock and key hypothesis is a poor description of what is going on. For a better understanding of the lock and key hypothesis, please go and watch my video on the wintermelon seed cracker hypothesis. You can find the link in the description below. Proteins are polypeptide chains, and they bend and fold into 3D structure. Some as complex as these have bumps and grooves depending on how the protein is folded. Enzymes are protein, and they too fold into unique 3-dimensional structure. This 3D structure of the enzyme gives it the ability to catalyze chemical reaction. So how a protein or enzyme is folded is depending on the amino acid. Remember, your amino acid has its unique R group. So the R group of the amino acid will interact with each other, causing the enzyme to be folded into its unique shape. The bond between those R groups are not very strong, so they can be broken down by heat or extreme pH. Remember, amino acid can be polar and non-polar, as well as acidic and alkaline. So pH and temperature will affect the bond between those R group, affecting the folding of the enzyme. So the enzyme is down here, then the active site is down here. The active site is a hole or a groove in the three-dimensional structure of the enzyme. The shape is complementary to the substrate. The substrate or the reactant molecules involved in the reaction is catalyzed by the enzyme. The substrate will be converted into products. So when the substrate binds to an enzyme, it forms an enzyme-substrate complex. And when an enzyme-substrate complex is formed, it will lower the activation energy for the chemical reaction to take place, because the enzyme will affect the bond within the molecules, either weakening it or strengthening it. Therefore, it will require lesser energy for the reactions to take place. So for a chemical reaction to take place, it requires a certain amount of energy to be reached. Without enzyme, some molecules need to reach a high level of energy for reactions to take place. So now let us take a look in the case of when there is enzyme. So the enzyme will lower the activation energy by bringing the reactant molecules into the correct orientation for the reactions to take place. So once the enzyme-substrate complex is formed, the reaction will take place. The enzyme remains chemically unchanged at the end of the reaction, ready to take in another reactant molecules. So in summary, enzyme is like a lock because enzyme have an active site, while a lock have a keyhole, which is meant for the substrate to fit in, like a key fitting into the keyhole. Substrate fit into the active site of the enzyme. The active site of the enzyme is complementary to the shape of the substrate. Each of the active site is unique to the shape of each unique substrate. Now, the keyword down here is complementary. Complementary as opposed to identical. Why is it important? Because if we say the shape of the substrate is identical to the shape of the active site, that means it is like saying that the shape of a Coca-Cola bottle is the same as the shape of the Coca-Cola cap. They look different. They are complementary rather than identical or the same. Enzymes speed up chemical reaction by forming enzyme-substrate complex. And by forming enzyme-substrate complex, this will reduce the activation energy required for a reaction to take place, because the enzyme will interact with the substrate, causing the bond of the substrate to be weakened or strengthened, allowing the reaction to occur at a lower energy level. So that's all for this lesson. In the next lesson, you will learn factors affecting the rate of enzyme-catalyzed reaction.